live. All right, and this is the part where it's always a little bit mystifying when exactly the stream starts, but it looks like we're up now. All right, excellent. Once again, welcome to the August user session. You can see this on Zoom. We have a few of you here on Zoom, and then anybody that wants to can view this on YouTube, and then it'll be archived on YouTube. So you can always go back or share it with somebody else later if that makes sense. We are going to be talking about two things. We're going to talk about using seff to profile our jobs on the cluster. And then after that, we're going to talk about using Singularity containers. So we're just going to get started right on it. So I'm going to share my screen. And specifically, I'm going to share my terminal because this is where you're going to be using seff if you use it. Let's see, for some reason the chat window, all right, there we go. I want to make sure I had the chat window up in case anybody asks questions. So seff is going to be something that you primarily use on the command line. And it's really, really straightforward to use, and it's installed everywhere on the cluster. So you just have to, let's see, somebody's trying to get in. Hang on a second. Oh, Robbie's got it. All right, sweet. So in order to get seff to work, all you need to do is type in seff. Okay, go upstairs, bud. Mama can help you. So my 2-year-old has potty trained himself, but he still needs the encouragement of other people. So that's what that's about. So anyway, so seff, so it stands for Slurm efficiency. At least that's how I remember it. And if I just hit that without putting a job ID in, it'll show me the help. And so what happens is there it says, you know, you can put other options in, or you can just put a job ID in. So I went ahead and, so if you just run saccount, then that'll show you the jobs that you've run in the last 24 hours. I went ahead and ran saccount for the past couple of months. So we would have a few different ones to try from. But first we could take this last job ID here and pop that into seff. And then you can see there, this is the data that gives us out. It tells us who ran the job, what state the job is in. So this job is completed. The utilization of the job, I think this is, I'm not really sure what minute, this looks like minutes or time. So this is probably CPU minutes, maybe.
Yeah. In the total job, how many minutes was the CPU being utilized properly?
Yeah. And then the CPU efficiency. So this is, I guess this 13% would be, that 18 or 2 minutes divided by 18 to compute the, because this is the core wall time. So I asked for 4 cores, but I didn't use all 4 cores the entire time the job was running. And so the CPU utilized divided by the core wall time. So the core wall time would be the number of cores that I requested times the actual amount of time on a clock on the wall that the job ran. So that makes sense because this is the job wall clock time. So the job actually run, I experienced the job running 4 minutes and 33 seconds, but there were 4 CPUs. So 4 times 4 minutes, 33 seconds, you get 18 minutes, 12 seconds. And then I only utilized 2 minutes of that core time. So then, and then also I only used 1 gigabyte of memory, even though I requested 16 gigs of memory. And so my efficiency was 7% there. So I requested more than I needed. Let's see if we go back to, all right, so Jupyter jobs, I'm gonna expect to be even less efficient than that because this is an interactive job. And so, yeah. So if we look at this, the job ran for 12 hours because that's just what I requested it for. But then I only used a fraction of that. And so it's saying I used 0.01% of the CPUs that I requested, which that's not 100% fair for characterizing a Jupyter job, but because you kind of use it a little bit and then you might have to think a little bit before you code some more. So that makes sense. And let's see, we can go back more here and look at one of these other jobs. So this is something from an array job where it was running a pretty hefty neurology pipeline. And if we put in seff and that job, then we can see the efficiency of this is better than the other couple ones that I've looked at. So it's saying that I have more like 20% efficiency. This is a parallel MATLAB code, and I know it needs some optimization, but I got it from someone else. But it really does take a long time to run. So actually, this is reasonably decent for what it was. But this is a really fast way if you think that one of your jobs canceled because of memory usage. You could always take a look at this and it will tell you actually how much it did use or attempted to use, as well as other ways that you could optimize your job, because like in this case, it's saying I'm only using 21% of my core wall time. Maybe I bring down the number of cores per node that I ask for this so I can get it scheduled more often, but then I'm going to expect that it's going to run for a little bit longer, because even if you have a parallel threads, it doesn't mean all of those threads are going to be running 100% of the time. So yeah, I wouldn't expect to keep my 3-day wall time for this job if I lowered the number of cores. But this does say that I could probably lower the number of cores and still get it done in less than the 6-day window of a long job. So I might be able to schedule more of these jobs and in the end get the whole workflow through the cluster faster.
Yeah, and one really nice use case for this seff command or executable or script, it's that you can basically profile your jobs. So like we always talk, and most of you people follow the same method. You prototype with one portion of your complete data set, and then you try to create your workflow. You see which softwares work, okay, what's going to be the flow of your entire workflow. So the first time that you are creating that prototype that you are going to apply to rest of your jobs with batch processing, you can also check how much memory your job is going to be requiring with how much memory your job required in your prototype workflow. Like we always suggest, whatever is the value that you get at the end. So like in this job from William, we see that his memory utilization is 8.96 gigabytes. So that memory utilization will also depend upon what data he is inputting to the script that he is writing over here. So generally we tend to say that add 20% to 40% of the memory to this to whatever is the memory utilized, and then run your batch scripts on that number. That way you are asking for the least amount of RAM at which you think your job should run successfully, that means that your jobs are going to have higher priority and they are going to start faster. Just because you're asking for if you ask for less resources, then Slum scheduler has to do less work in going out and finding those resources for you. So like if you ask for 200 gigabytes of RAM and you are only using 2 gigabytes of RAM in real time, then by asking for 200 gigabytes of RAM, you have already excluded a bunch of nodes that would have been useful since you are only using 2 gigabytes. Uh, so you have excluded those nodes. You have a limited number of nodes in which your job would actually or can actually run based on the resources that you asked for, and uh, and that means that your wait for your job to start. I mean, it would take the same amount of time whether you asked for 4 gigabytes or 200 gigabytes. But the wait time before a job actually starts moves from pending to running state. That's something that you can decrease by optimizing how much memory you're asking for, how many hours you're asking for in the job, and all that.
Yep. Well, and so we did have a couple of questions. So first one was, do we have a cheat sheet for the commands that we use with the options that we like to use? And so unfortunately, we do not have that kind of cheat sheet readily handy. But fortunately for us, it looks like Mana shared his in the chat, and it has the information here on seff. Mana, would you mind if we posted that link to the YouTube chat as well for anybody watching there? All right, excellent, excellent. Well, I'm going to share that because that's a really nice resource. So thank you, Mana. Thank you for being willing to share that. It does have this seff tool in there, and I'm looking at it. It's got pretty much everything else that we use as well, with really helpful just kind of default parameters to use. So that's really helpful. Can you use multiple job IDs with seff? I don't know the answer to that. Oh, my internet connection is unstable. Unstable.
Yeah, you hung there for a while.
I blipped out there for a second. All right. All right. So Mana's asking, can we use multiple job IDs with seff? Yeah, I don't know. I don't think so. Ravi, do you know the answer to that?
Using multiple no, but what you can do is you can create an sort of an array of these jobs and then run seff on that.
Oh, okay. Like do it on in like a bash for loop or something.
Yeah, and
I wonder what happens if I run it on.
I think William's internet is acting up. We'll wait for a few seconds for him to come back and.
All right, my internet keeps on blipping in and out, but Ravi, I think at this point I'm going to hand it back to you to talk about Singularity.
All right, and so let me share my screen. All right, so today we are going to talk about Singularity. We have done this tutorial before. We just thought that since it has been some time since we talked about Singularity, we thought that it might be a good idea to refresh our memory and of people who have already attended the previous session. I think this would be a good platform. And for people who didn't attend, this would be a nice introduction to Singularity. So we will base our session today on this Git repo. So it's rc-training session Singularity Containers. Let me post that on in our chat so that you guys have. All right, I posted it in Zoom chat, so you guys should be able to just go to this GitLab project. And basically, so what we do need to do first is we need to set up this Git repo on Chiha. And so basically, it's super simple. We need to go on to on-demand interface, and sorry. Yeah, so we first need to run this portion using Job Composer. What it basically does is it takes a look if you already have this folder, data user RC training sessions. If you don't, it creates one. It also checks if you already have the Git repo pulled last time. And if you had already put it last time, it's just going to try to update it rather than pulling it. Else it's just going to pull the Git repo. It's going to have a fresh pull for that. So I've already run this once, but let me show you guys how this is going to work. So you are on a on-demand interface, that's rc.uab.edu. You go over there, you sign in using your Blazor ID and password. You should come to actually this page. And under jobs, you go to Job Composer. From new jobs, select a default template. And over here at the end of on the right side, just open editor and paste it. And you save it and then you submit this job. Once you submit the job, like all the things that I mentioned, it's going to go and create the proper locations on Chiha for you, and it's going to pull the Git repo, this RC training sessions, Singularity Containers Git repo for you. I already did it. If you see, it's the same thing. And so I already have the latest version of Git repo. So I'm not going to submit it. If you guys have any issues when you submit this job, send your message. Let us know, and we can take a look at what your issue might be. So once you have that, you have already set up the Git repo. You need to start a Jupyter notebook with these two settings. Everything else depends on you, but just having these two settings is going to get you in a proper place in the Jupyter notebook. So you go to, again, on-demand interface, you go to interactive apps, start up a Jupyter notebook, and an environment setup, you copy this where you're loading Singularity and Anaconda 3. Singularity would allow, is going to put the Singularity system, container system, in the environment of the Jupyter notebook that's running. And Anaconda 3 is required, so that's the place where the Jupyter notebook is actually present. So if you copy these two over here, I think that's the current setting that I have. I have module load Anaconda 3 and module load Singularity / 3.5.2 GCC. This module, you don't need to worry about rest of them. I already have commented them out, so they are not loading anyways in my environment. And then in extra Jupyter arguments, you specify this parameter -- notebook -dir and data user $user, that's a Blazor ID, RC training session, Singularity container. So that's what our script initially did. It created this folder. And then it pulled on the Singularity containers Git repo. Like I mentioned, everything else totally depends on you. You can ask for 48 hours like I have over here with 2 CPUs and 12 gigs per CPU memory over here and partition as medium, or you can choose 2 express. One should be fine, and I think 4 gig should be more than enough. And then you click launch and you should come to this page. I already have a session running just in case this one takes a bit of time. I know Chiha is a little bit busy nowadays, so it might take you 5-10 minutes to get the job. So just in case it takes that long, I already have a session running where we can start. All right, it didn't. And so first thing you'll see is if you straight away click on connect to Jupyter, you are going to see this failed to connect to this. That's why we have this message over here that if you see this, wait for about 5-10 seconds and then click on this button. And by that time, it should have established connection with the Jupyter notebook that's running on a compute node and that port number. And you should not see that error. Like when I'm running again, I don't see any issue. All right. So after that, you just go ahead and click on the singularity underscore container.ipynb. So when we are discussing singularity containers, I think the first easiest task is that we just go ahead and try to pull a singularity container and try to play around with it a bit. And then we can go into a little bit of theory about what a container is and how is it useful and what are the different types of containers that are available. All right, so let's pull our first container. So the first container that we are trying to pull is a Debian Singularity image. And it's a large collection of popular neuroscience research software. It's there are methods how you can install it on your own in Chiha. Like you can install it as a module or you can install it just in your profile. But that's a very time consuming and not necessarily a very simple process. It's a bit more complex. But with Singularity, since somebody has already built the container for us, it's as simple as just pulling down that container and being able to run all the different softwares that's available with NeuroDebian. Second complexity that arises when you're trying to build this NeuroDebian Singularity image is, like the name suggests, the second part of the name, Debian. It's mostly based on a Debian-based system, that is Ubuntu and other systems that are Debian based. On Chiha, we basically have an RPM based system, and since it's a CentOS system, and so it's not like you can't build the NeuroDebian on CentOS, but you also have to keep in mind that the dependencies that are there for NeuroDebian software collection, you have to find an equivalent package in CentOS before you can actually install the dependencies, and then you might have to make or further changes in trying to build that NeuroDebian software collection. So like I said, complexity, and then there is another layer of complexity just because all the documentation and everything, it's most likely that all the documentation would be available in Ubuntu term rather than CentOS term that we have on Chiha. And both of those issues get solved by Singularity. We are going to see that. So first of all, let's just check which version of Singularity we have, which version of Singularity we are running. I know we already loaded the module Singularity. It's just good to see that the Singularity is really available on Chiha or available in this Jupyter Notebook environment. You'll notice that I have exclamation point before all the commands that I run in each of the cells. What this exclamation point does is it tells Singularity that this is a system command. So it, rather than trying to go through Python interpreter and and considering it as a Python command, it considers it as a system command and tries to run it directly on the sort of command line version. So basically, if you typed in this command directly on the command line, it's equivalent to that once you have that exclamation point. So let's run that. And so like we loaded 3.5.2. So this is a nice sanity check that the correct version of Singularity is the one that's running. And next is just we are trying to pull this Debian. So somebody has already created this S image, right? So it's on Singularity Hub. That's what this denotes. Sure. And there is a group called Debian who have decided to make this, expose this software as a Singularity container. And that's what we are just going to pull. And we are giving it a specific name over here. So once it downloads with the latest version of Singularity, so all the previous versions, all the 2 dot something versions of Singularity, they used to pull the images and they used to give the file type as simg or simg. That's short for Singularity image. But since version 3 onwards, they all the pulls that you do using Singularity, they give it a file type of seff or Singularity image file. So since a lot of our, like I mentioned, we have already done this tutorial before. A lot of our commands later on are going to be looking for this .s image. That's why we just specified a name over here so that whatever it pulls, it's going to give it this name. And that's the name that we have been using later on in this tutorial. If you don't want to, you can just remove it. Just keep in mind what's the name of the container that's downloaded and change it. Change this to that name, and you should be fine. It should run the same. All right. So I have already tried it before, and so I already have the image in the cache. So Singularity doesn't need to go ahead and pull that image again. It can just use the cached image and be like, okay, here you are. You have the Singularity image that you asked for. The first time that you guys are going to running it, you guys are going to see a progress graph that this is how much it has downloaded. I don't think the size of the image is too large, so it should not take that long. It should be about 10-20 second pull from Singularity. Let's take a list of all the files available. So you see we have this S image now in this folder. All right. So now let's try to execute a command from within the Singularity container. So executing a command is pretty simple. You just do a Singularity exec name of the Singularity container that you have on your file system, and then you run the command. And once we run this, you'll see, so this is equivalent to how if I just ran ls/home/$user, this is what should be the output. But now this command is being run from inside the Singularity container. The home directory gets mounted automatically. We are going to come, so for all the other file locations, we are going to discuss them a bit later. But just seeing this, example of running ls home directory, you guys might be wondering that, okay, why did we need to run all the things before that? Why couldn't we just run it on the container? Because that's not the actual command that we are trying to run. So one of the commands that's available in this Debian software collection is dicom to nifty. So if we wanted to just run, where's the insert? All right, so if we just try to run dicom to nifty, we should get this error, command not found, because our environment doesn't have any dicom to nifty. But if we run this Singularity exec and the name, and we are just running die count to Nifty, this container does have die count to Nifty. So once you run die count to Nifty over here, it gives its help function and everything. So there are several ways of considering how you're running the Singularity container over here. First of all, it's running as a process. You can run this command on the command line. So it starts up as a process on Chiha, and you can run whatever are the softwares that are available within the container in the same process. Other method is that if you just ignore this portion, it's like you're able to run your software directly. So just keep it if you just think of it as you are writing the path to the software, that might also be something that you might want to consider if it makes it a bit easier to understand how you can use Singularity containers. And yeah, so what is a container? Container is basically a standard unit of software that has the actual software that you want to run plus all the dependencies, may whether they be system libraries, any of the Python packages, R packages, or anything else that you needed for that software to run properly. Everything is packaged into one unit, and that unit can be executed using a container system. So like we have the Singularity system where we are running Singularity exec, that's the Singularity system. You have a Docker system as well that runs the Docker containers. So you can run that unit of software, or it's an executable, and it's lightweight. It's lightweight because even though it looks like it contains the entire software, it contains the entire OS. It only contains those pieces that are required by the software to run properly. So, for instance, if I run this, this looks like what a normal uh, Ubuntu system is going to look. So NeuroDebian is Ubuntu based. So this is what an Ubuntu system generally looks like if you look at their root. But if you go into lib64, it's going to be very light. It's just going to have things that were really, really required by NeuroDebian, and it's not going to contain all the things that you see are there by default in an Ubuntu OS. And yeah, so it's a little bit similar to virtual machines, but like in virtual machines, you have virtualization of the hardware. Container is more virtualization of the software. Like I mentioned, it runs as a process on top of the already running OS. So like in this case, like with this Jupyter notebook, we are running a container that is Ubuntu based, but we are running it directly on Chiha, that is CentOS based. So it can use different kernels from CentOS to achieve different functions. If you want to find more differences between VM and a container, you can follow this link, and it gives a nice description of the differences as well. So why use a container? We already talked about a lot of different advantages that you have. First of all, you have containers packages together a software and all its dependencies. Secondly, it gives you a consistent performance across different OSs. The only thing that it requires is that container system, either Singularity or Docker, to be installed. And then that container would run identical on whichever machine you choose. So if you're running one container on Mac or CentOS or Ubuntu, its characteristics are going to remain the same just because it doesn't need any dependencies from your OS. It already has all the dependencies in the container. So it's not like you're going to run into that this library is not found or that library is not found, so it would not run properly. Plus, since it runs as a process, it's easier for us to incorporate it into a Slurm job. So once you are once you have pulled the container which contains the softwares that you need, then you can just create a Slurm job. And so, like you were using Tycom to Nifty, like it was already installed in Chiha, you can just write that entire command in Slurm job as well. Docker versus Singularity. So, if you have heard of containers before, I'm pretty sure, or at least 95% sure, that it's in the terms of Docker rather than Singularity. Docker is pretty famous. It came out way before Singularity came out, and it's used by a lot of large firms nowadays. It's uh, it's it is pretty mature as well. I think I don't find much negatives about Docker except for one. I mean, so Singularity was built with HPC in mind. That is a shared resource. So Docker was built with a different use case in mind. Docker was built where you are where you are the owner of a machine. So it doesn't matter if some of the processes are running as root, like in Docker they generally do, uh, just because their use case was like you are the owner and the entire machine is just going to be running Docker containers. That's like I forget that architecture. Um so there's an architecture that's very famous nowadays, where all the services are on Docker containers and all the Docker containers talk to each other. And it's like you can divide up your services into very basic units that can be incorporated into Docker containers. Uh, I don't think I mentioned it over here. Oh, yes. So Lewis mentioned it's the microservice architecture. And so that is very famous, and Docker is widely used for that. But Singularity, like I was mentioning, is built for HPC environments. That is a shared environment. That basically means that it respects the security architecture that we have built onto an HPC system. That is, I as a user can't go and look into William's file locations without William explicitly giving me permission to look into those file locations. Or I can't go in as, or I can't try to maneuver to be root and try to increase my privileges on the cluster. So with all the security considerations, Singularity is super famous on HPC systems. There would, if it is a shared resource, there is a very, very good chance that you're not going to find Docker on those systems, but you are sure to find Singularity on those systems. One thing is, since Docker was very famous and a lot of researchers and everyone tried to incorporate their softwares on Docker, so what Singularity did nicely was it had some back compatibility with Docker images. So you are able to pull Docker images directly with Singularity. And we are going to take a look at one example where we pull a Docker image as well. So, and Singularity is already available on Chiha. If you want to see different versions that are available on Chiha, you can just use module avail Singularity. I would highly recommend using the latest version because it has a lot of new functions, a lot of enhanced functions. It's more secure. And there might come a time when we just might remove previous versions of Singularity. So if you keep your workflow in line with the latest version of Singularity, I think that might be the best uh, option going forward. And like William was mentioning, it also has built-in support for NVIDIA and GPUs. So uh, that makes it another advantage why you should use the latest version of Singularity. So what are some of the basic Singularity command line functions? I mean, it's super simple. I think they have a nice executable where they provide a lot of help. So if you just type in Singularity dash dash help once you have loaded Singularity, uh, I'm talking when you are on the command line and not in this Jupyter notebook. Once you have loaded Singularity, the latest module, and you can just run Singularity dash dash help, and you'll see what are the different commands that you can run with Singularity. You have build, cache, config, delete, and you can pull and push container images as well, remote. We are going to be talking about some of them. Shell is an interesting one. Shell is basically when you can just directly go into the container and try to run commands over there. It's basically like you are shelling into Chiha, right? Once you type in SSH, this. And so once you write Singularity shell and the name of that image, that's basically what it is like. You are directly going into the container and you can run some stuff. You would not be able to change it, especially on Chiha, unless until you have sudo privileges, you would not be able to change the container at all, but you can go in, you can take a look around the container and all that stuff. Uh, Build is also something for which you need sudo privileges. So this is basically when you're trying to build your own containers rather than trying to use containers that are already available on Singularity Hub or Docker Hub. That is something that we are not planning on discussing today, but we should. But we can have a session on that if you guys are interested. Just leave feedback that you guys are interested in finding out how to build your own Singularity containers, and we can have a session on that as well. Um, then there are different run command, and there is an exec command that we have been using for now. If you're more interested, if you're also interested in finding out some more help about any of these commands that you are running with Singularity, you can just type in Singularity, and suppose you are interested in what are the different parameters that I can pass with pull, then you can just do Singularity pull dash dash help, and that should give you all the different commands that you want to put. It also gives you how you are supposed to use it, uh, how to use this command properly. And so yeah, namespace resolution with the container. So let's try to run this. I mean, so we were able to run a list for our home directory. Now we are trying to list our data user. So you see the next lines that we have. Like I mentioned, we had this Jupyter notebook a while back. So even initially, at least in version 2.5 or something, it just errored out whenever you tried to ls for your data user location. But with 3.5, it has improved a bit, but there is still some error. I mean, I don't know if you guys can find out the errors straight away, but my data user location has way more folders than just this RC training sessions. So what it has done is it has improved, as in it can find the path where the Singularity container is running, and it includes that path as well in my location. So like if I just did an RC training sessions, it should another it should again have just one folder over here, Singularity containers, and even this folder contains multiple other folders for different RC training sessions that we have done. But this is the folder where my container is, so it has included this path as well. If you want to see all the everything that you have in your data user $user or data user location, you still need to bind your path to the container. So bind is simple. You just use dash uppercase B or dash dash bind, and you specify which path do you want to bind to this container. So I'm trying to bind data user and Ravi89 in my case over here, and then I run the same command, ls data user $user, and this time I get to see all the folders that are over there and not just that RC training sessions where my container is placed. It's useful because, like we always mention, home directory is only 20 gigabytes and data user location is 5 terabytes. So we always ask you guys to put your raw data in data user location. So you should be able to access it from a container. Otherwise, DICOM to Nifty is not going to be very useful if I can never access where the DICOM files are. So, and with this binding, you get access to your DICOM files that are there on data user location. And now you can just specify Singularity exec -b data user and then the name of the container, and then you can have DICOM to Nifty and then the location of the DICOM file, and it's going to convert it into NIF image. It still doesn't give me permissions. Like I mentioned, Singularity containers don't give me enhanced privileges. It gives me the same privilege that I already have on Chiha. So like if I was trying to be smart and just trying to take a look into what William was doing in his data user location, I still wouldn't be able to do it. Though I've specifically specified that, okay, go and bind this path and then take a look into this path. My container doesn't give me enhanced privileges. This is going to give me the same error that it will give me if I just did an ls/data user ws monroe on Chiha itself. So that's where the security comes in, and that's where Singularity comes in. That's the HPC was its main goal when it was created. All right, so like I mentioned, since it runs as a process, it's easier to incorporate into Slurm job scripts. I don't think we need to talk about these parameters. We have talked about them a lot anyways. But basically what you need to do is you need to be like, you load Singularity. So over here, you can change it to 3.5.2. And then you just run it as a Singularity or any other command. So it's a command, right? Like you just do Singularity exec-b. This is where the container is. I'm giving it the full path to the container. And then I'm specifying which executable from the container I need to run and the path to your DICOM files. So like I mentioned, if you think of this entire thing as a path to full path to DICOM to Nifty, I think that would be an easier thing to imagine at the start. I mean, eventually you guys would be able to imagine, okay, how it's happening with that. Where is DICOM to Nifty coming from? But yeah, if you guys can also consider it as a full path to this executable. All right. So like I mentioned, Singularity maintains a backward compatibility with Docker images. So like Google Cloud, they haven't built any executable or any of their tools for Singularity, but they have built their tools for Docker, which they make available by Docker as well. What you can do is you can just use Singularity pull command as same. The only thing that's changed is rather than Singularity Hub or shub, you use Docker because that's where it's pulling the files from, and then you specify the username and the full name to that container. You run that, and again, I think I've already pulled it before, so it's just like, okay, I don't need to do anything extra. With you guys, you'll see different layers that are being downloaded uh, with for this container, and then they all get merged together or squashed together to build a single seff file. And that's where you can find. So gsutil is one of the tools available in gcloud uh, command. So once I run this, you can see that gsutil is available. And if we wanted to again show that it was just gsutil, right? Yeah. And if I just try to run it without any Singularity, there is no gsutil on Chiha or in your environment right now by default. That's how containers can be useful. So one thing that I mentioned, I think it would be nice. I think that's all we have. This last one is just for cleaning a directory. So we have a seff image that comes by default if you just use Singularity pull without specifying the name. I also specified a name where I kept s image as the file type. So this this cell only cleans up your directory and removes both of those containers once you are done with your Jupyter notebook. But one thing that I mentioned while we were pulling down this Docker container was that there are you'll see once you're pulling it first that there would be different layers that would be downloaded. Containers are very layered kind of system. So to give you an example, the RStudio that you see on Jiha, that's built on a or a Singularity container that was just built for R. And so that's a layer on top of the R container. And R was built on another layer or another container that was just an Ubuntu base image or CentOS base image. So there are three layers to that as well. All the containers are where you can build layers upon layers upon layers. So, like for example, if I have this as the base, right? This just gcloud, it only has gcloud tool. I can build my own Docker container on top of this where I add AWS tools. So now my new one is going to have the base, that is gcloud tools, and something that I built on top of it, AWS tools. And that would be a new container. But it's a combination of 3 or 4 different layers of containers that are below it.
Yep. So we got a question. So since as users of the cluster, we don't have pseudo privileges, that would mean we can't build Singularity containers. And I think you were kind of alluding to this, the building Singularity containers is really helpful, but it's a little bit more involved than simply pulling them from the Singularity hub. So if you're going to build them, you do need pseudo privileges. And so what I've done in the past is create a CentOS 7 virtual box, a virtual machine on my local computer that I'm developing on. And then I build the Singularity container there since I have pseudo privileges there. And then I move that to Jiha.
Yeah, I mean, if you guys are interested, you also have the Singularity Vagrant. Uh, so if you are installing on a Mac or a Windows, you just go over there and they have already built Vagrant. I don't know what they are called, Vagrant boxes. So you already have Vagrant boxes that have Singularity inbuilt. So just like William was mentioning, you can build these Vagrant boxes and they start up on VM VirtualBox, and then you'll have a VM where you have access to Singularity and you have pseudo privileges over there. So you should be able to build your containers over there. There is another method where you can kind of build your containers, but that has some limitations. So if you take a look at Singularity Hub, so if you go to the singularity-hub.org, I think I posted the link in the notebook as well. So when it comes time to log in, you have to log in with your good GitHub credentials, and that basically means that Singularity has access to your GitHub projects, or not in a bad way. It's basically you can create your Singularity recipe files in a GitHub project, and then you can ask Singularity to pull that Singularity recipe file and build a container for you. So for instance, I have this Singularity-R built, right? And if I take a look at this GitHub, what I did was I asked Singularity to go and pull this Singularity recipe file from this project, and it went ahead and built the container for me without me having to run Singularity build or anything else. there are several disadvantages. You want to be in a system where you can test out this container before it builds on Singularity Hub. Also, you have a limit of 10 builds per day on Singularity Hub, just because they want to keep a control on how much resources are being used by different containers. They haven't made it limitless or unlimited. So you have a limit of 10 containers that you can try to build on Singularity Hub this way. But you still don't know if it's working properly till the time you pull down the container and try some stuff out or test that container properly. That's the reason you need a VM where you have pseudo privileges and you have Singularity where you can test those things out, build those containers, test them out, and after a lot of iterations, when you're sure that it's working fine, you push it to GitHub and be like, okay, Singularity, now pull that Singularity recipe file.
Yeah, that's really helpful, Ravi. So we have one more question, which is what happens if you bind the parent and the child directory? So like if you bind user/parent directory, and then you also bind user/parent directory/child directory. I think, and you can tell me what your thoughts are on this, Ravi. I think that it's not going to care because ultimately Singularity will let you bind any directory to the container, but if you don't specify a directory name for it to go to, I don't think you'd even experience any kind of weird behavior in this situation where you do the parent directory and the child directory. What I've seen weird behavior with is when I try to bind one of my directories into a location in the container that it's expecting something else to be. So like if I bind my user bin directory to the container's user bin directory, then I'm actually, by doing that, essentially just pulling out the things they expected to be in user bin and putting everything that I want in user bin. And so so you get kind of weird behavior that way, but I suspect that this wouldn't cause any issues.
Yeah, it shouldn't. Let's actually just try it. User. Yeah, it shouldn't because it already has the parent. So if you just have the parent, that's sufficient. You already get all the child folders from the parent folder. Anyways, like I mentioned, once I just had this, I could still see RC-training sessions and I could see all the different child folders that are available over here. But if I also specifically binded RC training sessions, let's just go ahead. Yeah, it's the same because RC training sessions was already there. It did not have any issues with binding that one as well.
Yeah, but there is an option that you can rename the directories just in
Yeah,
case you do have conflicting directories. So yeah, if you put the colon and yeah, so then yeah.
and
So here we'll still see RC training sessions as part of this.
but if I do an ls, if I
Yeah,
just do ls/, there should be RC training there too.
yeah.
Yeah.
So it's a little bit like having a symlink.
Mm-hmm.
Um, it it just it behaves as if that folder has that name, and if you somehow create a folder loop with those binds, it's that's just what's going to exist there. But I don't think it's going to throw any errors until you start using it. And maybe, specifically what can happen is if you use that colon rename function, overwrite what it expects to be in like data or bin or backup or user bin or something like that.
Yeah, and Mana, to your last question, it would act as bit similar to what we just showed over here. I mean, if you had your parent directory bind to a name, then in that name you should be able to find all the child directory and the rest of the directories that were there in parent as well. But in this location, in this specific location slash data user, you should just find that child directory RC training sessions. So it would be similar to this. And if I just bind this to /RC training, and I did a data user, now it should just have RC training sessions, because the rest of the things, just the parent data user, I bounded as RC/RC training. But in this location, data user, I just bound this path, RC training sessions.
Yep. Well, cool. I think that is pretty much everything that we had planned. Thank you guys for all the questions. Is there anything else before we sign off? All right. Well, in that case, if you guys have any more questions, feel free to email us, or you can always go to the YouTube channel and rewatch the video. And if you post comments there, Robbie and I will see it, and we'll try to answer there as well. But yeah, thank you guys for joining us, and we will we'll have another user session next month.
All right.